Alright, this morning we're going to start on 9.6, which is solving radical equations. Basically the same thing we did with 9.5, but of course we're adding a level of difficulty. And in this case you'll notice that we have radicals on both sides of the equal sign. Or in this case they're on the same side, but there's still two radical symbols. And what that means is you're going to have to square the equation twice in order to solve it. So this is a little more difficult type of equation. But the process, we have to isolate one of the radicals instead of both of them. We just have to isolate one of them and then solve, then isolate the other one, then square equations, and then solve. So let's go through and look at this first one. There are two isolated radicals. So what we're going to do with this is we're going to, and I'm going to show each step, we're going to square both sides, and then we're going to square the x plus 15, the square root of x plus 15, and we're going to square that. Now when you square square root again, the radical lifts, so you have 3x plus 1 equals x plus 15, and then we can just solve like we would have solved an equation. We can subtract x from both sides, which gives us 2x plus 1 equals x plus 15. And then we're going to subtract 1 from both sides, which then gives us x, 2x, equals 14, and of course the last step is always dividing by 2, so x equals 7. Now again we have to check. You have to do that check step, because if you don't, occasionally you're going to have one that doesn't work. So we have the square root of 3 times 7 plus 1 equals the square root of x plus 15, or 7 plus 15. We just put what number we got, which was 7, in there for x. This gives us the square root of 21 plus 1, or 22, equals the square root of 22. Well, that's obviously a correct statement, so x equals 7. That number was good, so we can write that as our answer. Now let's go on to problem number 2. And in problem number 2, again, we have two square roots, but they're on the same side of the equal sign. So obviously the first thing we need to do is to get one on one side and one on the other side. Now, since there's a minus right here, I'm going to add the square root of x minus 2 to both sides. So that adds out to be 0. And we have the square root of x plus 3 equals 1 plus the square root of x minus 2. Now we have to square both sides. And this is where knowing that a squared plus 2ab plus b squared for squaring a binomial is handy for this part right here. And so I'm going to go off to this left side here and list, in that case, a is equal to 1, so a squared is equal to 1. B is equal to the square root of x minus 2, so b squared will be x minus 2. And then 2ab is going to be 2 times 1 times the square root of x minus 2, okay, or just 2 times the square root of x minus 2. So remember, and I'll write it up here at the top of the page, for solving radical equations, if you have a plus b squared, that will multiply out as a squared plus 2 times a times b plus b squared. And if you have a minus b squared, then that will multiply out as a squared minus 2ab, and that's a little harder to see because I'm writing over some writing, plus b squared. Alright, so we have that hopefully you remember from a few lessons ago. So what part of this do we need to square this? Well, we need to have our a squared, our b squared. So we need this, and we need 2ab. And that's all going to replace the multiplication of this binomial 1 plus the square root of x minus 2 squared. So let's x plus 3 squared just gives me x plus 3. Okay. Now that's going to equal 1 plus 2 times the square root of x minus 2 plus x minus 2. That's your b squared right there. Okay, now we combine what we can. We can combine this 1 and this negative 2. And so you're going to have x plus 3 is equal to negative 1 plus 2 times the square root of x minus 2 plus x. Okay. Alright, so now we've combined what we can. We're going to have to then bring everything over to the left of the equal sign and leave this. Let me change colors a little bit if I can. Go back. We're going to leave this part right here by itself. So that way we'll isolate that square root. So we're going to add 1. Move up here. We're going to add 1, and we're going to subtract x from both sides. That makes that 0, that's 0. And on this side, that x happens to cancel out, so we have 4 equals 2 times the square root of x minus 2. Okay? So, now, I'm going to write that up here and go over. We have 4 equals 2 times the square root of x minus 2. Now we can divide by 2 on both sides, which leaves me with 2 equals the square root of x minus 2. Now, if you cannot divide by that 2, or whatever the coefficient is in front of that radical, that's okay, just square the whole thing. But if you can divide and it comes out nicely, and with a nice whole number answer, go ahead and do the division, because now when I square both sides, all we do is lift this radical, and so you have 4 equals x minus 2. Well, then when I add 2 to both sides, I have 6 equals x. So we're going to check and make sure that's a good answer, because if it's not, then we're going to have to take that off. So let's find a way to squeeze that check in here. We'll put our check here. Try to get where we can put it in there. Okay. Alright, so we have the square root of 6 plus 3 minus the square root of 6 minus 2 equals 1. Okay? And that's the square root of 9 minus the square root of 4 equals 1. Well, square root of 9 is 3. Square root of 4 is 2. And that does equal 1. So 6 is a good answer for us. Alright, let's look at, we have 2 more examples. And again, these are getting more challenging. There's no question about it. There's a fair amount of work with each of these problems. But, you know, hard work never hurt anybody, even in math. I know you don't like to hear that. But let's look at number 3. We're going to look at the radicals. They're here and here. This one on the left is already isolated, so we're going to go ahead, since we have one of them that's by itself already, we're going to go ahead and square both sides. So let's do that. We have the square root of 3x plus 4 squared equals all of this. Okay, so again, if you want to, you can use the a and b. We have a is equal to the square root of x plus 1, and b is equal to 1. So a squared is equal to x plus 1, b squared is equal to 1, and c is equal to 2, oh no, excuse me, what am I saying, not c, 2ab is 2 times the square root of x plus 1 times 1, or 2 times the square root of x plus 1. Okay, so for squaring, we use a different color so we can get our color coding in good shape. Okay. For squaring all of this, okay, then I'm going to use these pieces, and I didn't label this right. I'm going to use this piece, and this piece, and this one should have been b squared, because 1 times 1 is 1. Alright, so squaring this 3x plus 4, I end up with 3x plus 4 equals, and this one we end up with x plus 1, that's my a squared, plus 2ab, which is 2 times the square root of x plus 1, and then plus 1. I can add these two 1's here, which will then give us x plus 2 times the square root of x plus 1. On the right side of the equal sign, and on the left I still have my 3x plus 4. So I'm going to subtract x and subtract 2. Okay, those will add to be 0. And over here, 3x minus x is 2x, and 4 minus 2 will be plus 2, and that equals 2 times the square root of x plus 1. Okay? Now, if you think about this, this is the same as 2 times x plus 1 when I factor out a 2. If you can see that, that makes it a little easier, because now I can divide by 2, and those will both be 1. 2 over 2 is 1, so we're left on the left side with x plus 1, and on the right side we're left with the square root of x plus 1. Now we're going to square both sides, because anytime there's two square root symbols, you have to square it twice to clear both of them. If you FOIL this, remember that's the same as x plus 1 times x plus 1, x plus 1 squared. And so that comes out to be x squared plus 2x plus 1. And that's going to equal x plus 1. Okay. Subtract x and subtract 1. Subtract x and subtract 1. That becomes 0, that becomes 0, and that becomes 0. And so we're left with x squared plus x equal 0. Now this is a hard one, because a lot of times you'll think, oh, there's nothing I can do with that. What does that mean? Factor out an x. This factoring out an x will leave you x times x plus 1 equals 0. Now set your parentheses equal to 0. Anytime you have an x outside your parentheses by itself, if x is 0, then when I multiply these I'll get 0. And if x is negative 1, when I multiply these together. It's like factoring and you set your parentheses equal to 0. So those are my two answers, 0 and negative 1, which means I have to check two answers. So we're going to go up here, and we're going to say that x equals 0 and negative 1, and we may have to take one of those off. Remember, we have to check them. Alright, so here we go. We're going to do our check. And we have two answers to check this time. So first let's check 0. The square root of 3 times 0 plus 4 is equal to the square root of 0 plus 1 and then plus 1 out from under the radical. Alright, 3 times 0 is 0, so that ends up just being the square root of 4 plus the square root of 1 plus 1. The square root of 4 is 2. Square root of 1 is 1. 1 plus 1 equals 2. So 0 checks as being an answer that will work. Now we're going to check negative 1. So we substitute negative 1 in for x. So we have 3 times negative 1 plus 4. Again, we're putting this back in the original problem. Equals square root of negative 1 plus 1. And then plus 1 out from under the radical. 3 times negative 1 is negative 3, so that leaves me with the square root of 1. That leaves me with the square root of 0 plus 1. Well, the square root of 1 is 1. The square root of 0 is 0, so 1 equals 1, and that's going to give me a good answer. So both negative 1 and 0 work as answers, and so I leave them there. I don't mark any of those out. Again, it's very possible that one of these will not work for you, and then you have to put no solution or mark that one out. Alright, again on this one now, we've got two square roots. They're on the same side of the equal sign, so that means I'm going to need to move this one over to that side. And the reason I'm going to do that one's negative. So, let's go up and let's do our work. And we'll work as far as we have room. So I'm going to add the square root of x plus 6 to both sides of the equation. And that's going to leave me with the square root of 2x minus 2 equals the square root of x plus 6 plus 1. Okay. Square both sides. This one is easy. Now, oops, it's easy, but I did it wrong. Now we just have 2x minus 2. Okay, if we want to do our a squared b squared method, on this one we have a is equal to the square root of x plus 6. So a squared is equal to x plus 6. B equals 1, so b squared equals 1. And 2ab is 2 times 1 times the square root of x plus 6. Okay, so for squaring, and again I'm going to color code a little bit, we need a squared, we need b squared, and we need 2ab. And that's going to be the multiplication for that binomial on the right side of the equal sign. So what we're going to end up with is x plus 6 plus 2 times the square root of x plus 6 and then plus 1. So we're going to subtract. We can combine the 6 and the 1 and end up with x plus 7 plus 2 times the square root of x plus 6. And again, stop this recording and look at it And this is one good thing about the recordings. You have time to stop it and figure out. If you don't know where I'm getting something, stop it, study it for a minute, and then see if you can figure out where I got some of these answers or what I'm doing to get some of them. Alright, so I have, this is the radical part here. I need to leave that on the right side of the equal sign and move the x and the 7, subtract those over, or add them over. So I'm going to subtract x and subtract 7, subtract x and subtract 7 from both sides. Those two things add to be 0. So I have, and I wrote a 7 there. I should have written an x. That's an x. Alright, so 2x minus x is just x. We have minus 9 equals 2 times the square root of x plus 6. Okay, now here's where this 2 does not divide very evenly into that. So we're going to leave it where it is. So let's go over and write under here what we've got so we can kind of start a new bit. We have x minus 9 is equal to 2 times the square root of x plus 6. Now we're going to square both sides. Okay. And x minus 9 squared is x minus 9 times x minus 9. And when you multiply that out, you'll have a squared, which is x, minus 2 times x times 9, so that's going to be 18x, plus 9 squared, which is 81, is equal to, now I have to square this right side here. So 2 times 2 is 4, and then the radical lifts for squaring that, and so we have 4 times x plus 6. Now we're going to distribute the 4. So we have x squared minus 18x plus 81 equals 4x plus 24. Now we're going to set everything equal to 0 so we can try to factor. So we have subtract 4x and subtract 24. Those add to be 0. And so we end up with 0 on the right side of the equation. And on the left, we have x squared minus 22x plus 57 equals 0. Now we need something that will multiply to be 57 and add to be negative 22. And it so happens that we can do that with, if you factor 57, it's 19 times 3. That's the prime factorization. And so that works out because 19 plus 3 is 22. This negative and the first negative tells me that both signs are negative. So we have x minus 3 times x minus 19 equals 0. So what numbers make each set of parentheses 0? It's x equals 3 and x equals 19. So that's what we think the answer is, but we're going to have to check. Well, I'm out of paper, so I'm going to add a page, and we're going to check it on another page. So let's go up, and we're going to do our check here because I was out of paper on that side. So we're going to go ahead and check. All right, so for our check, we have to check the 3. We're checking x equals 3 and x equals 19. And I'll go ahead and write our original problem because I have room to do that now. And our original problem is the square root of 2x minus 2 minus the square root of x plus 6 equals 1. Alright, so first we're going to check our 3. Square root of 2 times 3 minus 2 minus the square root of 3 plus 6 equals 1. That's 6 minus 2, or 4, minus the square root of 9 equals 1, which is 2 minus 3, and that does not equal 1. So this one did not check out. Okay, it didn't get a false statement. So we know it can't be 3. Let's try 19. We have the square root of 2 times 19 minus 2 minus the square root of 19 plus 6, and we hope that equals 1. So 2 times 19 is 38 minus 2, that gives me the square root of 36, minus the square root of 25 equals 1. And so 6 minus 5 equals 1. Well, that one does check. So one of these answers works, and it is 19 and not 3. So if I go back to my other page and look where we wrote those answers, 3 can't work, but 19 does. So we have x equals 19 is our answer for number 4.